Welcome to a new test and teardown video. This time it's a Boonton type 202H FM-AM signal generator. It covers a 54 to 216 megahertz, and it can do FM and AM modulation at different frequencies. So this will be the modulation frequencies, and here we adjust how much AM or FM we got, and of course I bet when we change the modulation meter we also change modulation type, I would guess. Or maybe we can, I don't, that would be stupid, right? Or maybe we have AM and AF, we have the different modulation here at the same time, so I can do both. I will inspect that. So the frequency selection is done by two bands. So this is the low band and the high band, but see what happens up here. Nice mechanical solution. And the feeling is really, really good. So the mechanics in this is just super good. And look at this runs super smooth. So that will be 80 megahertz. And then I don't know if I'm happy about this, because look, so that is the megahertz step in 80, 75, blah, 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 blah. So this fine scale is divided into something else that isn't really, I don't know. That is a little bit weird, isn't it? And then we go to 0 here. So I mean 0, 0, that is fine. So this part of the scale is just divided into 100 finer of this, but it has nothing to do with the megahertz scale. So what is the idea about having this? I don't know. Of course, this is a frequency fine adjust. I think this is what you need to calibrate. So if this is 55 exactly, or if it is not, then you fine tune here. Okay, now it's correct, and then 54 will be correct as well. I would assume this is a fine calibration. And what is this? So that is a mechanical lock. Yeah, okay. Pretty cool. So this is of course the output level. Oh. And that is some RF drive. Because this thing is tube based, there is a feedback system in the output drive and the oscillator parts, and we need to adjust this for the correct drive. So it just says adjust to red line. Okay, so if RF drive is at the correct level, then this scale here will work. And then the on-off switch. If you noticed anything by looking at the buttons, yes, this looks exactly like HP. The whole front plate design, handles, case, everything just smells far away Hewlett-Packard. And that is because Boonton is indeed a Hewlett-Packard company. Just so you know. It is also written on the back here. Let's see the back. So this is the rear. And look at that. 3 amps heater, I guess. That is what it is, right? since I live in 230, I think this is why this was modified. But they didn't remove the text up here. Or maybe the back side of this label. Maybe you move it like that. I don't know. They changed the fuse, so the fuse is 1.5 amp and it is not broken. So that is good. And here it says Hewlett-Packard as well, right? And the classic old style mains connector, and of course I keep those cables. And the center pin here is chassis, as you can see, and it is very, very important to use a power cord with chassis to earth for protection. Otherwise you could get electrocuted. This is an old tube-based instrument and we want to think about safety. And we are ready for the first power up. Switch is off. I think we're just gonna go for it. Let's crank this sucker up. That is how we do it. And nothing bad happened. And 100 watts, 113, 90, 80, 70. Why is this not lit? Yippity yip. We saw something. 80 watts. Hey, we got... It's responding to this button. Ha ha. That is good. Then Habba output. And let's look at this. 60 megahertz. However, what is this? I see some funny stuff. That's probably some modulation. Okay. Of course I'm gonna go and get a spectrum analyzer instead of this crap. Okay. What I see here is some nothing. Okay. I will have to play. Oh, this is of course because modulation is off. Oh, AM. So this is how we select AM here. But why isn't this connected to this? Why do we need two buttons for that? Okay, AM. Ha ha. Oi, oi, oi. This thing can do AM. Yeah, we got AM. Tons of AM. We can even do all the way to smash. I mean, it's truly working. Oi, oi, oi. So I just put a little receiver here. Adjust it to 145. Just to listen to noise and stability and whatever is going on inside this unit. This is of course FM. Okay, so far, I mean, it's really stable, but you do hear a little bit of. Can you hear this? But this is of course a free swinging thing. It isn't in lock with anything at all. and the level is very, very low. It is, be quiet. It is very, very tight. There isn't really a lot of stuff escaping. See? If I stick in anything here, smash, I get super, super high power signal, right? So this is just because leak in the connector, leak in the cable. But it's amazingly weak compared to sticking in a little bit of an antenna here. So, well, ooh, this one is funny. But I mean, it's, oh. That is expected. So now, where is it? It's here. It's drifting a little bit. Anyway, I will open this thing now. Let's have a look. And we are inside. I just took out the bulb. Of course there's a bulb. I guess this is from the modulation oscillators. That is my best guess. It's really dirty, so I'll go and clean it up a little bit outside and give it some compressed air and see if I can make it nice and pretty. You can see this is, let's have a look. Nice, huh? And yes, here are the adjustments for mains voltage. We see some transistors for different power supply things, as far as I understand. I've been looking a little bit on the schematics, and I'm very sure that I now understand why we saw the little jittery thing on the output, and that is because it actually consists of an oscillator and a Doppler, and again a Doppler amplifier, the last stage. And this is what you select when you go here. You see the frequency is exactly the double of that, right? But then there's actually also the main oscillator is actually running half of this. So there's a Doppler here, and then it's doubled again for this output. And this is why you see a little bit of jitter when you look on a scope. Look at this beautiful, beautiful thing. I don't know if I can show you. This is the switch to handle the Doppler enable, and this is the frequency adjustment. So that means all the cool stuff is done inside this can. I don't know if we're able to open this real easy. It looks like it's really sealed and connected to a lot of stuff, especially all the mechanical things here. So that's probably not that easy. Maybe I can take off the lid, like just unscrew this, unscrew that. That is definitely something I want to have a look at, if that is possible. This whole unit is also hanging in a little bit of a flexible coupling, so they're trying to avoid mechanical interference. Something like that, right? It definitely requires a cleanup. let's look at the bottom of this unit. Probably an inductor for high voltage filtration, rectifier bridge. I need to be careful not to touch anything. Ooh. Especially this one, see? 450 volts. This is the output coupler. See, this is the output level, and this is maximum, so it's all the way in, so this way we get as much output as possible. Mechanical attenuator. That is so nice. And this is the connector for filament voltage grid, RF level detection and all that for AGC and all that. So all you have to do is unplug this, and then you can pull out the entire oscillator section here. And there's this little a mini BNC connector. Look at that. How cute is that? Let's try and compare this to a normal BNC connector. That is so cute. I like that. Better put that back. Yeah. There is a little problem, I guess. Look at that. V400 is not mounted, or somebody stole it. But this is in the FM frequency adjustment. This is a cathode follower. So maybe for some reasons they figured out they didn't need it and just bypassed this signal, because it actually works. This button for remember, frequency fine tune and FM modulation and all that, it actually works. So that means this tube is not important for some reason. But if I look here, see, it is connected. So why is it those features actually works? That is a little bit strange. Maybe I should look a little bit deeper into the schematic, but I already did that and I couldn't really see it that easy. Oh yeah, look at the massive the two brass plates you see there, they're really, really big and heavy. Wow, look at that. So there's also a switch connected to something that's doing some fancy stuff outside of the unit. And they connected this via a gearbox. That is a very complex way to do this. So what is that doing? Okay, yeah, this is my pants. I just love it when it's super complicated and super nice mechanical solutions and all that stuff. And look at that plate. Is that brass or is it copper? That thick. This is 5 millimeters. Oh, that one is worth a lot of money. This is crazy. Yeah, but it's just, yeah, top quality. But I really want to see if we can get inside this. Oh yeah, don't you just like that one? Normally you don't see it in that many sections. It's only 2, right? But here we got 3. And there's also a stop here. And there's also a stop down here at exactly the same position, see? And then the stop, see? To the left and to the right. When it hits the screw. Doing, doing. So we got 2 stops. Why is that necessary? I don't know. But that is damn nice. Probably not touch this, it's greasy. I don't know if you can see this. When I was pulling this off, I just had a feeling. I don't know if you can see it. Can you see it? Doesn't it look a little bit like I'm like disarming a bomb or some shit like that? It's just crazy. It really looks like some kind of funky shit, this, man. Oh yeah, we got 3 sections. Ooh, that's some grease. So let's try a little bit and play with it. All the mechanics is just absolutely amazing. So it's geared in here in 3 fantastic sections, and then it's just full of all the most amazing things. It is beautiful in here. It really looks brand new. Of course, this is completely sealed, so there is no dust or nasty stuff in here. So there's the inspection stamp, 57. Is it really that old? And then there's another one down there. I don't think those stamps, they actually is this 57 after, because I think this unit is from 61 or 62 or something like that, right? So it can't be that. And here we go with the 3 different tubes. One is a like a regulator tube, oscillator, and a doubler, and the output power. Brand new. That is so nice. I don't want to poke around here and take them out and put them in again or anything, because frequency alignment is really, really good. And I don't want to mess up the super good performance of this unit. But of course we can have a look at the tube. The different tubes here. This shouldn't bother the settings. So yeah, there's not a lot more to see here really, as far as I can see. I'll probably going to flip it around and have a look from the other end, see if there's any more stuff I can see. Now it's open. By the way, when I was looking around here, this is something I don't like. So what exactly happened here? Somebody cut or drilled a hole in this pot. This can't be good. Why? It's a really weird sound. It's probably full of stuff that is not supposed to be in there. And this is the bottom side of this. Yeah, okay, of course you need more capacitance change per setting, because this is the oscillator and that will be the doubler, right? And the last one, look, there's almost nothing. Haha! So that is of course how it is, look. There's, I don't know, can I show you this? There's an annoying wire in the way. But look at that. Yep. And then that will be the last stage in here is of course the output, and then this is the output coupler, that thingy here. Yabba dabba doo. And we've seen this system many times before in a lot of other HP products. So this is the oscillator section we've just been looking at. So this is of course the schematic of it, and here we see the three capacitors, or the three variable capacitors, and of course they go smaller and smaller and smaller in size because the frequency goes higher and higher. And here is the output attenuator. They try to explain it like this. I don't know if this is real easy to see what is going on. So this is the tube I was talking about, that one. Let's zoom in a little bit. So V400 is missing in the socket, and the node is the A tube is not used because we got two of those in that tube, right? But one of them is indeed used, but somehow it just works anyway. Isn't that a little bit funny? So nothing comes out here, there's no current going this way, but still the variable frequency adjustments and all that stuff here, it's all working, and we got FM and everything. So I find that a little bit funny. I think it's just going this way instead, right? Or just there's a capacitor here, and this just goes this way anyway. So I mean, because there isn't any gain in a cathode follower, so it just seems to be working somehow because of the impedances, or somebody put an inductor here or another resistor or something over that one, so that could explain why it's working. Yeah, so that's funny. And here is the audio oscillator, exactly as I said, and here's the bulb compensation for the level. So this is a typical way to make a nice stable oscillator. It handles all those different frequency ranges. I think actually my unit goes a little higher than this, but that's just there are some variations. And there's also a note here that says it's identified as I500, and it is in my unit